All right, welcome back to problem solving, the ratios and fractions, percents. So here's what we're going to do. We're going to look at what happens when it's inversely proportional. Okay, so let me go ahead and share this. Okay, and pull this down. All right, and let's have a look at our problem section here. And do this. Grab this problem. Okay, again, it's going to run off the page, but that's okay. Oops. Okay, Control V. Okay. So here we have it. All right. So it says when a tire is inflated, the air pressure is inversely proportional to the volume of the air. Okay. If the pressure of the tire is 23 square inches, okay, PSI rather, pounds per square inch. Then the volume is 130 cubic inches. Okay, what is the pressure when the volume is 150 cubic inches? All right. So this problem. Well, in the previous ones, remember we did like P1, P2, and if it was just proportional, right, we'd have a V1 and a V2, but they're inversely proportional. But inversely proportional, right? So it's P1, P2 is equal to V2, V1. See, it's upside down. That's what inversely proportional means. Okay. I'm going to go one more thing here before we go and jump into this problem. But there's our setup that we would like. The way I learned this, because this is a chemistry problem, was we cross multiplied. And this is the format that I learned this thing in. Notice all the ones are on one side and all the twos are on the other side. And that's kind of what that's kind of how I remembered this. So if it was inversely proportional, specifically the pressure and volume problem, I just set up all the ones on one side and all the twos on the other side, and then we'd solve for what we needed. Okay. So in the context of what we're looking at though, okay, we have a P1, right? Pressure of a tire is 23, so P1 is equal to 23. Our V1, right, is equal to 130. Okay, again, the hardest part of it, this is kind of getting this through here. Volume 2 is 150. And P2 equals, well, I don't know. Okay, so what we're going to do is we're just going to set this up. So P1 is 23. P2 is P2, because I don't know what that is. V2, right, that was 150. And V1 was 130. Okay. So what we're going to do is we're going to say 23 times 130 is equal to 150. I am recording, okay, times P2. Okay, so what's going on here? We have 23 times 130, 2990. So this is 2990 is equal to 150 times this pressure I don't know. We're going to divide by 150. All right, there's a semicolon there. And then we're going to have P2 is equal to, right, 2990 divided by 150. So here we have 2990 divided by 150. 19.93. Okay. Okay, so let's have a look at what's going on here. Round to the nearest tenth, 19.9. So there we go. So that's an inversely proportional one. Sometimes they tell us they're inversely proportional. Okay, like the problem that we just did was inversely proportional. I think number 9 does as well. It's the draining pipe. Okay. If a tank is inversely proportional to the cross-sectional area of the pipe, or the time required to empty a tank is inversely proportional. So sometimes they tell us, which would be, this isn't too bad. Sometimes they don't tell us. Okay. So what happens if we look at something like number 4? Okay. So a crowbar is, we're looking at a torque. Okay. So if you've worked on cars at all, if you've done any like high school physics maybe, what we're going to have for torque is the units for torque are in foot-pounds, right? So what we're looking at here is that we want the force and the length on one side to be equal to the force and the length on the other side in order to make this thing equivalent, to make the the lifting power the same as the weight. Okay, and the longer the arm, the more leverage you're going to have. Okay, so this goes back to, right, if I go ahead and do some magic here, cross multiplying here, this is going to equal L2 over L1. So we can see that's also going to be an inversely proportional sort of a piece here. Okay, so I don't know why they choose to make you remember certain pieces. Say, well, you have to memorize this one, but you don't have to memorize that one. So I don't really know why they've done that. I mean, sometimes it's pretty obvious for, especially for the directly proportionals, but if they're not directly proportional, sometimes like, how are you supposed to know? Okay, so let's go ahead. I'm going to try to make another page here. Sorry, add a page. This is what, 4.2, page 5, I guess. So we're going to have, what section? 4.2, page 5. All right, and then we're going to copy that in there. Okay, and we want force 1, force 2. We want to be equal to L2, length 2 over length 1. So it's inversely proportional here. The reason I picked this problem as well is because we're given a crowbar, right? There's a crowbar. And they're saying you want to put, it's pivoted 8 inches from the end. So what they're saying here is that there's 8. Okay, or this distance here is 8. Okay. Okay, well, let's keep that, just delete the little piece I have here. Sorry. All right. If the whole thing is 25 inches and we've lost 8 of them because it's on the other side, 25, and then we have 8. What is that going to be? That's going to be 17. So this is going to be 17 inches. Okay. So we have what force must be applied to the long end, that's over here, okay, to lift a 500-pound object on the short end. So this guy here, this is 500 pounds. Okay. So we have a length, but we don't have a force. Okay. So what we're going to do is we're just going to type these things in. We have a 500, or we have a force 1, which we don't know. We have a 500-pound force on the other side, weights or forces. Okay. And then equals L2, that's going to be 8 inches divided by 17 inches. Okay. So again, we look at this, we say, okay, well, 17 F1 cross multiplying is equal to 500 times 8. Okay, what is 500 times 8? That should be like 4,000 equals 17 times F1. And then we'll have F1 is equal to 4,000 divided by 17, and we'll see where we end up. Okay, so we have 4,000 divided by 17. And there we go. That's 235. And then we'll take a look at what we need. Okay. Here's 10th. That's what we have. 235 point. This 9 will round this up to a 3. So 235.3. 235.3. Okay. And then we're all set. So I think that will do it for us. So that was one of the big ones I wanted to make sure we got to, because it's a little tricky with the way they set up the crowbar. I wasn't sure exactly what they were talking about, like how are we supposed to set this thing up, but that's what you do. Okay. So try one more. It's been a short video. Question 2 again. Okay, so this is one they don't tell us it's inversely proportional here either, do they? No, they do not. So I'm not sure exactly why, again, that they decided you're supposed to just know some things and some things are going to let you know. I don't know. But, we have a line shaft here. Okay, this is our line shaft, 200 RPMs, attached to a grinding wheel down here, by the system shown. And they said if the grinding shaft must turn at 1,200 RPMs, what should be the size of the pulley on the other end here? Okay, so let's go ahead and take a look at this. So we are going to have, again, this would have been kind of nice to plug this in, but okay, we have a piece here. Okay, this is what, 200 RPMs, and we don't know just the diameter. We have no idea. Okay, forgive my drawings. If anybody says you have to draw something, or if I ever say, please draw it, if you could draw as well as I do, which is like 3rd grade level, and I'm being unkind to the 3rd graders because they could probably do much better than I did. Okay, this is 4. And we have a grinding wheel. So this is some kind of an RPM here, and this grinding wheel is attached to it, so it's going to spin at that value. Okay. So what we're going to do is we're going to have our diameter 1, diameter 2. Okay, but it's inversely proportional. So we're going to have our RPMs, our rotation 2, divided by our rotation 1. Okay. So we can start filling some stuff in. So we don't know what diameter 1 is. I have no idea what this is. Okay, but the diameter 2, we know that this is 4. Okay, rotation 2, they describe that to us in the problem. We go back and we say it has to turn at 1,200. Okay, so this is going to be 1,200. That's down here. Okay, and we start off at 200. Okay, so if you see easier ways to do it, and you want to take a little bit of shortcut without going through all of that, you can do that. Okay, diameter 2, by the way, this was 4. Okay, so we're just going to go through and cross multiply again. Okay, so we have 200 times our first diameter, because that's what we're trying to find, and then we have 1,200 times 4. Okay. So we have 200 times the diameter, I don't know, is equal to 4 times 12 is 4,800. Okay. And then we have D1 is equal to 4,800 divided by 200. Okay. We can cancel some of this out, right? The 2 zeros are going to go. If you don't trust yourself, there's always a calculator. I'm not going to, not judging. And then 48 divided by 2, that should be 24. So it should be your 24 inches there, what they say. Okay. 24 inches. So, yeah. As we get closer to the quiz, I will let you know if you have to know one of these. Other than that, I think I provided a hint last time. I said, by the way, this is inversely proportional. So it wasn't something you had to carry around. You just had to know how to handle an inversely proportional problem. You have to know how to handle it. I don't think I told you if they're direct. I think I just let you go with that. Because if I pick something like salaries or your pay versus time, you know that that is directly proportional. Okay. But inversely proportional could be a little tricky to spot. So like I said, I think I gave that one away last time. I can tell you that's what this is. Right. So hopefully that that helps some of the harder ones. And yeah, I'll see you in class. All right. Thank you.